Alrighty, I think we'll get started here. Welcome everyone. Today we're doing a demo about printing electronics with carbon ink. Um, yeah, so we'll just get started. I'm just going to start off going through kind of the plan for the next hour or so, and then we'll jump right into it. So today we're going to be printing with NovaCentrix HPR-059, which is a black carbon ink. We're going to do a little bit of a presentation to start with before we get into the print. And in that, we'll go over just carbon inks in general. And then we might go into, or then we're going to go into why you might want to use the NovaCentrix ink specifically. We'll take a look at how carbon sensors are used on Nova, and then we'll move into printing carbon ink onto a rigid substrate. And then during the print, we'll be focusing on using the mounting hardware for rigid substrates, and we'll be diving into the alignment process in a bit more detail in Nova software. So throughout this presentation, feel free to ask any questions you have. We have Gio and Tom at the ready to help answer those questions. And if anything isn't answered during the presentation, feel free to reach out to us afterwards at the email hello@volterra.io. It's also on the bottom of our slides here, so if you forget, and I'll mention it at the end as well. So without further ado, why don't we jump into the slides here? So like I said, we're doing printed electronics with carbon ink today. So I wanted to just start off by talking a little bit about carbon ink. So yeah, we're going to talk about carbon inks. Then we're going to focus in on the ink we'll be using today, the NovaCentrix HPR-059, and why you might want to use it. We'll talk about the uses in Nova, where we use carbon ink, and then we'll do our print demonstration. Perfect. So carbon inks. Yeah, so what's kind of one of the big benefits to using carbon inks? Mainly their versatility. They have a wide range of uses and applications. They come in a ton of different uses. So we'll jump right into that here. So some of the properties of carbon inks. They're very durable. They have high resistance to abrasion, scratching, flexing, and creasing. So this makes them great for just wear and tear in general. Most of them are chemically inert, so that means they're going to have low reactivity to solvents and other types of chemicals. They have a high conductivity, so they're great for a wide number of applications where conductivity is important, and they have a strong adhesion to silver inks and a wide variety of other substrates. So when you're printing with a silver ink and then want to print, say, a carbon resistor or a potentiometer that interacts with those silver inks, carbon ink is a great option for that. So like I just mentioned, some potential applications for those, for them. We've got resistors. So we've got a picture of what that looks like over on the left. We've also got potentiometers. Carbon ink, you can do printed potentiometers. You can do heaters with the carbon ink. Membrane switches. And then there's a variety of other potential applications here as well. So you can print polymer thick film circuits, RFI shielding for flexible circuits. You can do anode coating for capacitors, just flexible sensors in general. There's a lot of medical applications for carbon sensors. It's really great for static elimination and many more things. So kind of what makes it so versatile is you can pretty much load it up with any of the resin types out there as somebody who's formulating an ink to give it different properties for different types of applications. So the resin is the part of the ink that actually cures and makes it solid after the curing process, which makes it kind of robust and able to withstand wear and tear at the end. So like I've got listed here, you can use a thermoplastic, thermosetting, epoxy, silicone, water-based, and polyamide resin types with carbon ink. So like I said, this gives it a wide range of curing methods. So there's kind of a formulation of carbon inks out there for any application. And then for application methods, direct dispense is a great option. We might be a little bit biased on that. But it can also be then directly translated into screen printing or flexographic for larger scale manufacturing. Like I mentioned before, you can dip, like with capacitors, but it also works with inkjet. It can be sprayable. You can be pad printed and stamped. So it's a really very versatile material. So NovaCentrix HPR-059, which was what we're going to be printing with today. I just wanted to touch on some of the selling features of this ink and why we kind of chose to use it for today. So HPR-059 is a water-based black carbon resistive ink. It's got really good adhesion, and because it's water-based, it has the added benefit of just water cleanup. So you don't even need really any solvents at hand when cleaning up. It's a joy to work with when you're just wiping down the calibration plate or the XYZ sensor, or just having to take another pass at your print if you need to wipe it up and try again. Really easy to work with on that front. But yeah, it's ideal for paper, plastics, glass, and metal substrates. Yeah, we've just found it works pretty much really well with anything we're printing onto it. Just a couple of quick tech specs. Of course, there's a more robust version on their technical data sheet on the NovaCentrix website. So feel free to head over there if you're really curious and want to get into the real meat of the material. But it has a very, very small particle size. So we're talking 0.15 to 0.25 microns for the average particle size. And that's just incredibly small. A lot of the inks that we regularly print with, like the ink we regularly stock, is about 10 to 15 microns. So yeah, an order of magnitude larger than this. As for resistivity, you can see here we've got 0.7 to 0.9 ohms per centimeter, and a curing temp starts at 100 degrees Celsius. We're going to show you a cured example a little later on today, and we cured that at about, I think, 130 degrees for about 10 minutes just in an oven, and it turned out really great. And like I mentioned previously, the cleaning fluid, you can just use water, which is really awesome. Keeps it nice and simple. So, yeah, I mean, the main reason we decided to go with the HPR-059 is its ease of cleanup and its great printability. So I just wanted to dive into carbon inks in Nova. In the past, during webinars, we've seen folks ask for some practical examples. And so our machine itself has a couple of really great examples of where carbon ink can come in handy. And yeah, just wanted to dive in a little bit on that to give you a practical example. So just going to start out with a problem we were trying to solve when we were looking at yeah, calibration and sensing our tools on developing Nova and how we wanted to make our machine as repeatable and accurate as possible. So I'm just going to go through a little bit of a thought exercise here, and I think it'll all come clear once we get into the meat of it here. So say you're doing archery with your friends. Should you be impressed if your friend's arrows are accurate? Maybe. Yeah, they're able to hit the board, and yeah, the accuracy is pretty good. You might be impressed. Should you be impressed if your friend's arrows are precise? I mean, probably not. Precise doesn't mean that they're hitting the bullseye every time. It just means they're able to sorry for the distraction there. If we could just make sure everybody's on mute, that would be great. So yeah, if your friend's precise with their arrows, it just means they're hitting the same spot every time. Doesn't necessarily mean that they're hitting the bullseye every time. So like I said, you're only going to be impressed if their arrows are both accurate and precise, right? We want them to be, if they're aiming for the bullseye, to be hitting the bullseye, and then if they're precise, they're hitting the bullseye every time. Now, should you be impressed if your friend's arrows or precisely hit a target with a higher resolution? I mean, no. If there's more rings on the target, it just means we have more defined area of where the bullseye might be. So in summary, accuracy is how close the arrows land to the bullseye, whereas precision is how close the arrows land to each other in repetition. And the resolution is how many rings are on the target. So accuracy doesn't equal precision, and it doesn't equal resolution. Just because a system has a really high value in one of them doesn't mean it's going to be a good system overall. We want kind of all three of these. We want high accuracy, high precision, and high resolution. So what does this mean in Nova? So on Nova, accuracy, if you tell Nova to go to a certain position, how close does it get to that actual position, right? For precision, if you tell Nova to probe position X number of times, let's say 3, how close are those measurements going to be to each other if we take a look at the measurements? And resolution, if you tell Nova to move in the Z-axis, what's the smallest distance it can move in the Z-axis? So we're going to take a look at the V1 touch sensing, just to give you some context on our past and why we were looking for a bit of a better solution. So the calibration switches on the V1. This is kind of how the machine figures out where the tools are in 3D space. So we've got 2 switches here. The one on the right is for the Z or the height, and then the one on the left is for the XY positioning. So the XY uses lever switches. So we've got 4 of them kind of in a compass formation. And the V1 interacts with each of these switches kind of one after another, and it takes a measurement of the difference between the two to find the center of the tool. And for the Z switch, it's just a button switch. And so when the tool comes down and interacts with the switch, it takes a measurement once it feels that it has been hit. So what are the downsides to switches? Moving parts are very likely to break and fail over time and after repetition. As you can see with this example here, ink can easily get into them. Because our tools are dispensing the ink and we need to find the center of the tool, sometimes the ink gets dispensed inside the switch, and over time and lack of cleaning, it can be difficult for those switches to function properly. And there's many factors that affect this type of setup, such as contact resistance and uncertainty about the distance the lever had to travel before the switch actually triggered. So in the V1, we're going to look at the probe as well, because it takes a part of the height measurement. So the green cap of the probe is kind of like a bullseye as well. It's got a bullseye in the center and then kind of an outer ring on the target. So the outer ring comes in contact with a spring, and the center shaft also makes contact with that spring. And so when the center shaft is depressed upwards, it makes contact with the center of the bullseye, and we get contact. This is also a type of switch, basically, when you break it down, and it can have misalignment problems and some inconsistency in the probe force required, especially probe to probe. So let's take a look at Nova touch sensing and how we used carbon ink to resolve that. So instead of using switches, we moved it towards sensors. So from a moving switch to a steady state sensor. So we'll take a look at the XYZ positioning system. You'll notice that this is just an all-in-one instead of 2 separate areas on the V1. So we're using what is called a strain gauge for our measurement for these tools. So they are printed carbon resistors, and basically when they are compressed, they're less resistive, and when they are stretched, they're more resistive. So you can see that kind of here in the picture on the right. And so this is what the strain gauge sensors look like on the XYZ calibration tool on Nova. So you can see on the bottom side, we've got the Z sensors there. We've got an array of 4 of them. I'm just going to head back. So we've got 4 of them there. And then on the XY, we've got 8 of them. So 4 for each direction. And so this is kind of what it looks like when tools are interacting with the XYZ positioning tool. So you can see for Z positioning, when the tool comes down and makes contact with the top of the button, we can see how those 4 different resistors are going to react. So the outer ones, they're going to see less resistance because they are being compressed. And we're going to see the closest ones to the tool are being stretched. And so their resistance is going to read higher. And so that's the difference between the two is we can kind of calibrate and know that the tool has been touched. Similarly with the XY positioning, so the tool will make contact with 4 sides of the tool, much like it does with the V1. Just instead of hitting from the inside, it's hitting from the outside. So we're still getting kind of a compass north, south, east, west type of points. But in this case, the resistors act a little bit differently. So the outer resistance, when the edge is touched, the resistance will go down. As we can see, it's being compressed. And then the one closest to it here is going up. But instead of the Z positioning where the opposite side mirrors it, the opposite side is flipped. So we can see the resistance go down on the closest one and the resistance go up on the furthest one. And so that's how we know which side is being touched based on those resistive values. So the smart probe, how does it work? It's very simple. Another strain gauge sensor. So we can see that printed here. And keep this image in your head because it might look a little bit familiar for later on when we go to do our practical print. And yeah, just kind of one thing to note with the probe is the noise level of the probe is less than a single step in the Z-axis. So we can basically discount the probe as not being a source of any height uncertainty, which is really nice. So the result is we get a more accurate and precise because there's no moving parts and no mechanical parts. And we also get higher resolution because the small deformations of the PCB can be detected, which is great. So it's great to talk about it, but what does this mean in the numbers? So we can kind of see the V1 XY accuracy, Z accuracy, and XY and Z resolutions here compared. One thing to note just with the Z accuracy of the V1 is in practice, this is probably around plus or minus 30 microns just because of the probe and Z switch. There's lots of moving parts going on, so they all kind of compound a little bit. But if we were just taking the Z switch itself, it's 20 microns plus or minus. But we can see Nova's basically knocking it out of the park on accuracy and resolution here. And then you might have one comment here. Well, the V1 has higher Z resolution than Nova. Technically, yes, the V1 does have the ability to take smaller steps in the Z axis. But practically speaking, we're not printing height differences of about 0.6 microns. So the resolution is also meaningless considering the accuracy and precision as well. So that difference gets completely thrown out the window when we've got the accuracy here, 16 micron difference between the two machines. Perfect. So yeah, I think we'll jump into our print demo and get printing. So I'm just going to switch over here to Nova software. And if this is your first time taking a look at Nova software, I'll just give you a quick overview. If you're a V1 user, this should look fairly familiar. In the center of the screen, we do have our workflow tiles. So we have dispense, materials, and calibrate. Across the top, we've got a couple quick interaction buttons. So we've got the home button for homing the gantry and the tools on it. We've got a quick stop button. We've got a message support button. And we've also got the support chat in the bottom right-hand corner as well. And then we've got our settings button. And this is specifically for the print settings for the ink that we're going to be using. And since we're not in a workflow right now, these settings don't mean much. And then we've got a couple other machine settings here across the bottom, but I don't think we'll need to get into that today. So for today, we're going to be dispensing a material that we've already previously calibrated. If you're interested in the calibration process, yeah, feel free to reach out to us. We went into a bit more detail on the calibration process in our last webinar, and we'd be happy to send that video recording out to you as well. So today, since we already have our material calibrated and we already have our substrate added into our materials library, we're just going to jump right into the dispense workflow. So I'll just click dispense to get that started. We're going to skip creating a job. And I guess one quick note is basically all the actions we're going to take interacting with the software are going to happen here on the left-hand side. Our work area is going to be right in the center, and then we'll get some helpful tips and tricks popping up on the right-hand side as we work through the workflow. The create job is there for anytime you're doing a repetitive job where you're going to be using the same ink, the same substrate, and the same file. You can save all those as a job just to get the next few steps a little quicker. But we're just doing a bit of a one-off print here today. So I'm going to skip it, go to the next step. So our first step is to choose our materials. So for the paste, like I mentioned a little bit earlier, we're going to be printing with the NovaCentrix HPR-059. That's our carbon ink. And then as for substrate, we're going to be printing onto an FR4 board. Great. Now that I've got those selected, I can click next. And now I'm prompted to load my file. So I'm just going to choose a file from my computer here. Strain gauge. Awesome. And you can see Nova quickly generated the tool paths. We can zoom in here and take a little bit of a closer look. But yeah, we're seeing, as you can see, this is a fairly simple pattern. Yeah, we're just basically going to be printing some carbon resistors onto our FR4 board to create a strain gauge sensor. But yeah, the tool paths loaded in, great. Once they're green, it basically means that we've been able to generate those. So we'll click next, and it's asking us to mount a substrate. And you can see we're getting a great helpful graphic here on the right-hand side that we can interact with. This is giving, because we selected an FR4 board, which is a rigid substrate, it's giving us directions on how to use the mounting hardware to set up a rigid substrate. So yeah, I think we'll jump into that right now. I'm just gonna switch view here, and I'm just opening up the drawer just to highlight the foam insert that comes in the drawer. And you can see our rigid mounting hardware here on the left-hand side. So we've got two types of rigid mounting hardware. We have an anchor mount, which is basically just a screw. It screws into the grid system on Nova. And it's also got a little hold down cap on the top that you can unscrew and tighten up to pinch down onto pieces. So we'll be using one anchor mount. The anchor mount's a great starting point for any board that you're mounting because it's just really sturdy and you can pivot off of it. And then our other type of mount is the swivel mount. So it's very similar to the anchor mount in that you can unscrew and use this top screw for pinching. But the swivel mount has this slotted section so that you have a bit more freedom and flexibility on the mounting grid. So it doesn't have to be specifically just right up and down on one of the 40 by 40 grid holes. You can slide it around and have a bit more flexibility that way. And to lock the swivel mounts in place, we have a thumb screw, and that's what goes inside the slotted mount area. So I'm just going to grab our board for today. Like I said, it should look a little bit familiar. We'll get a little bit of a closer view from Nova's camera. Additionally, we'll send some pictures in the follow-up email so you guys can have a better view. I know it can be a little bit difficult to see on camera, but this is quite a small board, so I'm just going to probably use about 3 mounts today to get this locked in place. So I'm just going to start by pinching it inside of our anchor mount with one corner. There we go. And it'll just hover in place a little bit. And I'm going to loosen off my swivel mount. And I think I'll use this hole over here. So I'm just getting it loosely in place so I can lock in this corner. And then I'll lock in the swivel mount. And I mean, this is pretty sturdy already. But I'm going to do one thing that we recommend doing for rigid substrates, especially the larger they get. It can be good to add a couple swivel mounts just underneath the PCB as well. So all I've done is I've taken the thumb screw portion of the swivel mount off the top, and that allows me to just slide it underneath the board. And that just gives it some support directly in the center so that it doesn't deflect when we go to probe or when we go to actually print onto the substrate. Perfect. So I'm just going to make sure everything's nice and tight. I'm just going to test with my finger to see if I can feel any deflection. Because if you can feel any deflection with your finger, that means that the probe is definitely going to measure some deflection there, and you might get some inconsistent print results. But I think for today, this is pretty good. So I'm just going to zoom in and let you get a little bit of a closer look at what we've got there. Perfect. So back into the software. So we have mounted our substrate. So we can click next. So the next section is aligning our circuit to the substrate we just mounted. So there's a couple of portions to this. The first one is setting a pivot. So you can see in our help section in the right, we get a little bit of a definition of what setting the pivot is. So we use the mouse to select a feature in our design, and this feature becomes the pivot. And we'll position the pattern relative to this pivot point. So if I zoom in here, you can see I can select different features to be the pivot point, and then they're indicated with the crosshair. I think I'll use the top left for now, and then I'm able to set the pivot position. All right, so we can see Nova's just quickly homing itself, and the camera is centering itself on the thumb screw. Perfect. And we can see it went, as its starting point, it's going right to the center of the work area. And we can always swap out the background and the camera depending on which we prefer using. So I can see that my design is probably a little bit further over here. So I can move it around this way, or I can swap it back and I can use the arrow keys on my computer. And then I've also got arrow keys here, and I can change the step value that those movements of these keys do by just clicking the center. So you can see I dropped it from 5 millimeters to 1 millimeter. I can also drop it down to 0.5, all the way to 0.02, so I can get really fine movements. But I think for now I'll use 0.5. And if you ever notice that the design looks a little small for what we're working on, so what happened when the printer focus in on the center of the work area. The center of the work area is about 3 millimeters or 30 millimeters, I should say, lower than my workpiece. So I'm just going to click the fix scaling button, and it's going to recalculate the millimeter pixel ratio on top of our substrate now. And we should get a much closer scaling example here. I also have the light turned off just for this camera over here. But if I turn that on, I should be able to get a little bit better results here as well. There we go. I'm also just going to focus really quickly. There we are. So I'm just trying to get this pad, the center of this pad in the center of where it should be on my board, and then we can work on rotation in the next step. So I'm going to drop the step size here again a little bit. Perfect. I think that's pretty close. So now I'll move to rotation. And you can see I've got these two arrow options. And again, we can change the step size for the rotation. So I can sit here and click, or I can go to advanced. And I can see roughly that this is pretty close to 90 degrees, just a little bit shy. So let's start with 80 degrees. Oh, not quite. We can go maybe 85. That gets us a little closer. 88. Oh, that's not too bad. And we can always go back to simple and manually run it here as well. Perfect. So I can click next. And here's the next step was where we're able to really fine tune the alignment. So we're going to take a picture of the substrate here. And then we'll be able to tune the alignment based on that picture with the AR overlay. There we go. So I've got the option again for rotation here. So we can just fine tune it a little bit here. And then I've also got the option to move around still. But this time I'm not moving the camera, I'm just moving where the circuit is in the AR overlay. And if at any point I think something feels off, I can always go back to any of these steps and try readjusting them as well. Okay, let's go next again. And I think we're pretty happy with that. So the next step is to probe our circuit. So I'll just click the probe button and we can see on the machine, the probe is going to interact here with the XYZ positioner tool. So right now it's just getting the height. And then it's going to go and hit all four sides of the positioner tool. And you might be able to see that the LED is just lighting up underneath here. So we also get a visual representation on the thumb switch as well as the probe itself when it makes any contact. And you might be wondering why it's probing the calibration area as well. So we're just going to do a quick flow check with our dispenser to make sure that ink is flowing before we start printing. And so it just needs to print or probe the calibration area. So we have a height map of that as well as our workpiece. So we're all set for the next couple of steps. And in the software, you'll see we've got a bit of a progress bar here on the left-hand side that lets us know how far we are in the process. And you can also see as soon as all the probe points are hit, they turn blue, and we know that it's completed that point. If there's any issue with the probing point, it would show up as red, and we would know that there's an issue that we can work with. But in this case, we're all good, so we can continue on. So the machine is advising us to prepare our dispenser. You can see that I've already got our dispenser attached with our ink inside, but we do get all the instructions here on the right-hand side of how to assemble our dispenser. Awesome. So now we can move to the flow check setting or flow check step. And you can see our dispenser is currently heating up here. That's the instruction we're getting just at the top of the page. Dispenser is heating up because we have our preheat temperature for our dispenser for this ink set to 35 degrees Celsius. And this is the standard for the settings that we provide. There's no real reason other than to give you a temperature that is greater than the average room temperature, so that if your lab is 21 degrees Celsius one day and then 25 degrees Celsius the next day, you're still going to have consistent print results because the dispenser is heating the ink up to 35 degrees Celsius. If you do have a more temperature sensitive ink, you can drop that temperature so that the dispenser won't heat up as well. Or if you need it to be a little bit warmer, you can increase it as well. But it'll take just a minute to heat up this dispenser, and then we'll be able to move into the flow check. And the flow check is not a calibration procedure. All we're doing is we're going to print a series of lines, one after another, and all we're looking for is ink to start showing up. So we're just basically priming our dispenser using Nova. For V1 users, they might be familiar priming their dispenser by hand, twisting the cap on top. So we're just doing that here in this step with Nova itself. So it's all heated up, so I can just hit check. And we're also going to see Nova position the dispenser now with the XYZ switch. So very similar to the probe, it's going to get a Z height touching the top of the thumb screw, and then it's going to get X and Y by interacting with the north, south, east, and west sides of the thumb screw. Perfect. So once it's done that, it's going to move over to the calibration area and start dispensing ink. So I will just turn the light off after this check, just so you can have a better view of it. I think it'll probably take a couple of tries for us to get some ink coming out here, because I'm not seeing any come out this first set of lines, and that's completely normal. It can take a couple of goes at the flow check to actually get the material to come out, which is why we do it instead of printing right away. Nova's just going to take a picture for us. It'll show up here in the bottom left. Oh, and we actually did get one of our lines. So I would be completely happy moving on to our print with this, but I'm just going to do one more flow check just so you can see it. I'm going to turn the lights off on the gantry just so you have a better view here. So we'll check one more time. Perfect. Yeah, and we're getting ink with each of these lines this time. And Nova will just take a quick picture of those three lines so we can see it in the software. And if we're happy with that, we can continue on. Yep, we can see all three lines are showing up there great for us. So we are good to print. You can see our print is ready to go here. And we do have a little bit of a help notice in the top right-hand corner. If we wanted to select just one feature to print with, we can do that. So the printed features will highlight in green. If we want to select multiples, We could select multiples, but by default, the entire print is selected. So we're just going to start by printing the whole thing, and then we'll be able to inspect it afterwards. Right, and in the software, the top left, you can see we do have a progress bar here as well, just letting us know how far along we are in the process. If we wanted to adjust any of these settings just quickly on the fly, we have the option to adjust the pressure here, or the dispense pressure or relief pressure, and we can change the size of the step that we are adjusting that here as well. But from my eye, it looks like we're getting a pretty good print so far. I'll zoom in on the last pad here as well as it's going. Perfect. So we're all finished up here, the print finished. So the next step is we have the option to inspect the print. So it's jumped over to the camera. Again, we can swap with the work area or the camera, just clicking the bottom left-hand corner here. And we can click over to let the machine know that that's where we want to look. And okay, I'm just going to turn the lights on again here so we have a little bit of a better view. Okay, so we can see with this print, our centers didn't fill in very well. So what we could do is we could just try wiping it up and printing again. So I think that's what I'm going to do. I'm going to try and get a better result this time. With the design, I initially had adjusted the trace space so those would fill in, but let's just try printing them again to get those to fill in. So I'm just going to back it off so I can access it. And like I mentioned earlier on, this ink is really easy to clean up just because it's water-based. So I can just take a Q-tip and just wipe it right off there. And Nova's gonna keep all of our print height settings for our substrate. And it still has our ink dialed in, so we probably won't even need to do a flow check. I'll just be able to clean this up really quick. And then we'll go right back and try printing again. So go back here into the print pattern. I will select all the pads and I will hit start again. I'll give you a closer view again of it printing. Okay, we're just finishing up that last pad here. And then we'll inspect our print, see if it did any better this time. So again, I can just click on the area where my design is, pop open the camera. Okay, yes, this time we got really nice filled in features. So my guess is the ink was just a little on the light side flowing, and it was starting the print from the centers and working its way out, and so it just hadn't quite started. So yeah, just doing another print, having the ink flowing a little bit better, we were able to get a really good result here. So if I wanted to, I could take and save a snapshot of this picture for later. I could also expand this to open this in a new window and take a little bit of a closer look. But I think for the purposes of today, I am pretty happy with those print results. So I can click next, and then I will just say my print went well. And this is where I mentioned earlier on, you could save this job. So if we wanted to do this over and over and over again, I could save this job, and it's going to save the circuit design. It's going to save the ink we chose. It's going to save our substrate, and it's also going to save the alignment. So if we keep this fixture or used a jig or 3D printed our own jig where the placement's always going to be the same, we could save that. If there's any portion we didn't want to, then we could just run a new job as well. So for now, I'm just going to click finish, and we're all done with the print. And so I'm just going to home the machine here, get the tools out of the way so I can take the print out and hopefully get a little bit of a closer view with the camera. So I'm just unscrewing the two screws at the top of the anchor and swivel mount here, and giving a little bit of a view to the camera here. Let me go to maybe the zoomed view. Oh, there we are. Okay, so you can see that just the two black carbon resistors we've printed onto the strain gauge here. Now I know this isn't a great view, so what we'll do is we'll take a picture of this one while it's still wet, and we'll send that in our follow-up email. And then I also have one that's been cured, and we'll take a picture of this one as well, just to show what it looks like after it's been cured. But yeah, I think for the demo for today, I think we've pretty much wrapped things up here. So I just want to thank you all for joining us today. If you do have any questions that we missed throughout the chat, feel free to reach out to us at the email address hello@volterra.io, and we'll get back to you there. And like I mentioned, we'll be sending out a follow email to everyone who signed up and showed up today, and we'll include the recording of this demo webinar, as well as those pictures of what the print finally looked like at the end. So you can take a little bit of a closer look. But yeah, for that, I think we're all done. So I just want to thank you for joining us, and have a great rest of your day.